There is a pattern that keeps appearing in the epidemiological data on macular degeneration, and it is specific enough that I want to talk about it directly. Women over 65 develop age-related macular degeneration at higher rates than men of the same age. The reasons are multiple and still being studied, but what the data consistently shows is that the gap in risk between men and women widens after 65, and that women who develop AMD tend to experience faster progression once the condition is established. That is not a comfortable statistic, but it sits alongside another finding in the same research literature, one that receives far less attention, and that is what I want to spend today talking about. Women over 65 who eat orange bell pepper regularly show meaningfully lower rates of developing macular degeneration than those who do not. The association is not subtle. It is not buried in a statistical footnote. It does not require a particular interpretation of ambiguous data to see. It is one of the cleaner and more consistent dietary correlations in the nutrition and ophthalmology research of the last decade, and it points directly to a single compound that orange bell pepper delivers in quantities that almost nothing else available in a standard grocery store can match. That compound is zeaxanthin, and if you have not heard that word before, I want to spend a few minutes explaining exactly what it is, where it works inside your eye, and why its absence from the diet of most women over 65 is one of the most consequential and most correctable nutritional gaps I encounter in my practice. Before we go further, I want to hear from you. Do you eat orange bell pepper regularly? Drop a yes or no in the comments. I am building a picture of where most people in this community are starting from, and the answer matters. And as always, everything I share here is educational. It is not personalized medical advice. If you have concerns about your vision or your macular health, please see a licensed eye care professional. What I want to give you today is the understanding that empowers that conversation, not a substitute for it. Your retina contains a central zone called the macula. It is a small patch of tissue, roughly the size of a pencil eraser, but it is responsible for virtually all of the vision you actually use to navigate daily life with clarity. Reading, recognizing faces, driving, seeing the fine detail in the world around you. Every moment of precise visual awareness you have experienced in your life came from this small zone of tissue. Within the macula sits an even smaller, more specialized region called the fovea. The fovea is where your sharpest vision originates, and inside the fovea there is a protective pigment composed of three carotenoids: lutein, mesozeaxanthin, and zeaxanthin. Of these three, zeaxanthin is the one that concentrates most densely in the foveal center. Research published in the journal Experimental Eye Research found that zeaxanthin accounts for approximately 75% of the total carotenoid content at the very center of the fovea, the precise zone where the earliest and most damaging changes of macular degeneration typically begin. This is not incidental. The fovea concentrates zeaxanthin because it needs zeaxanthin. It needs it to absorb the high-energy blue light that would otherwise damage the photoreceptors beneath. It needs it to neutralize the free radicals generated by the constant photochemical activity inside the most metabolically demanding tissue in the human body. And it needs it in sufficient density to maintain the optical filtering that keeps central vision sharp as the eye ages. The problem, and this is where the epidemiological pattern I mentioned at the opening becomes directly relevant, is that zeaxanthin is one of the most difficult nutrients to obtain in adequate quantities from a typical Western diet. Unlike lutein, which is present in moderate amounts across a fairly wide range of dark leafy vegetables, zeaxanthin is concentrated in only a handful of foods. Corn provides some. Egg yolk delivers it in a highly bioavailable form. Goji berries are an exceptional source, and orange bell pepper stands apart from virtually everything else in the standard grocery store because of the sheer concentration of zeaxanthin it provides per serving. A single large orange bell pepper contains between 3 and 7 milligrams of zeaxanthin, depending on ripeness and variety. Research on macular pigment density and AMD prevention has focused on daily zeaxanthin intake thresholds of 2 milligrams and above. The average American adult over 65 consumes approximately 0.2 milligrams per day. That is a tenfold gap between typical intake and protective intake. And that gap, accumulated over years and decades of a diet with almost no zeaxanthin-rich foods, is directly visible in the macular pigment measurements of older women who present with early AMD. A prospective study published in JAMA Ophthalmology examined the dietary patterns of over 100,000 adults across multiple cohorts over an extended follow-up period, and found that women in the highest quintile of zeaxanthin and lutein consumption had a significantly lower risk of developing both intermediate and advanced AMD compared to women in the lowest quintile. Importantly, the protective association was stronger in women than in men across the cohorts studied, which aligns with the hypothesis that women's elevated baseline risk after 65 may be partially mediated by factors that adequate zeaxanthin intake is positioned to address, including oxidative stress in the foveal tissue and the vascular instability that precedes neovascular AMD. The risk reduction associated with the highest intake category was approximately 40% for intermediate AMD and over 25% for advanced AMD. These are not marginal effects. In the context of a condition for which there is no cure and limited treatment options once central vision loss has occurred, a 40% reduction in risk from a dietary pattern is among the most meaningful preventive findings in the field. What makes orange bell pepper specifically important within this broader zeaxanthin story is not just the quantity it provides, but the additional nutritional context it delivers alongside zeaxanthin. A single orange bell pepper also provides more than 200% of the recommended daily intake of vitamin C. And the role of vitamin C in the aging eye goes beyond its general antioxidant reputation. The lens of your eye, the structure responsible for focusing incoming light onto the retina, is bathed in a fluid called aqueous humor that contains vitamin C at concentrations approximately 20 times higher than what circulates in the bloodstream. That concentration reflects the extraordinary demand the lens places on vitamin C to protect itself from the oxidative damage that, over time, clouds its proteins and produces cataracts. Women over 65 who maintain high vitamin C intake through dietary sources rather than isolated supplements consistently show lower rates of nuclear cataract formation in the long-term prospective studies. A major analysis from the Nurses' Health Study found that women with the highest vitamin C intake had a 33% lower rate of cataract progression over a decade of follow-up. The protection appears most pronounced when the vitamin C comes from whole food sources rather than supplements, suggesting that the cofactors present in the food matrix contribute to the protective effect in ways that isolated supplementation does not fully replicate. Orange bell pepper also delivers a meaningful quantity of beta-cryptoxanthin, a carotenoid that preliminary research has linked to anti-inflammatory effects in ocular tissue, and capsanthin, the compound responsible for the orange color, which has been studied for its antioxidant activity in models of retinal cell protection. These are not primary mechanisms in the macular degeneration story. Zeaxanthin and vitamin C are the lead compounds for eye health in orange bell pepper, and they are the reason the research keeps returning to this specific vegetable. But they arrive in a package of complementary nutrition that the retina does not experience in isolation, and the combined effect of multiple protective compounds working through different mechanisms simultaneously is likely part of why the food-based studies produce stronger associations than studies of isolated supplementation with a single compound. Now let me address the question of how to eat orange bell pepper in a way that actually delivers the zeaxanthin to your macula, because this is a detail that significantly affects the outcome. Zeaxanthin is fat-soluble. It cannot be absorbed through the intestinal wall without fat present in the digestive environment at the same time. This means that raw orange bell pepper eaten alone, without any fat source, will deliver a fraction of the zeaxanthin it contains compared to orange bell pepper eaten with a fat source or cooked in oil. Research has demonstrated that consuming carotenoid-rich vegetables without accompanying fat can reduce absorption by 50% or more compared to consumption with fat present. A drizzle of extra virgin olive oil over raw slices. A light roast in avocado oil, added to scrambled eggs cooked in butter. Any of these approaches creates the lipid environment that allows your gut to absorb the zeaxanthin your macula depends on. Cooking does not significantly degrade zeaxanthin. Unlike some heat-sensitive nutrients, zeaxanthin is relatively stable at moderate cooking temperatures. Lightly roasted or sautéed orange bell pepper retains the vast majority of its zeaxanthin content, while the heat disrupts the cell walls in a way that actually improves the release of carotenoids from the plant matrix compared to raw consumption. The sweet spot is light cooking, 5 to 8 minutes at moderate heat, rather than prolonged high-heat preparation, which can reduce carotenoid content through extended thermal exposure. There is one more thing I want to address before we talk about frequency, and it is the question of whether green, red, or yellow bell peppers provide the same benefit. The short answer is no, not equivalently. The color of a bell pepper directly reflects its carotenoid composition. Green bell peppers are picked before full ripeness and contain primarily chlorophyll rather than carotenoids. Red bell peppers are richer in capsanthin and lycopene. Yellow bell peppers have a modest zeaxanthin content. Orange bell peppers, picked at the specific stage where zeaxanthin accumulation peaks, consistently show the highest zeaxanthin concentrations of any bell pepper variety in comparative analyses. The color is the cue. Orange is the one. The frequency question is also worth addressing directly. Macular pigment does not build overnight. Studies measuring meaningful increases in foveal zeaxanthin density typically run for 12 weeks or longer. The macula accumulates these compounds gradually over sustained, consistent intake. 3 to 4 servings of orange bell pepper per week, each prepared with a fat source, is the kind of consistent dietary contribution that the research suggests can shift macular pigment density measurably over a period of months. 1 large pepper, roasted and added to eggs. Half a pepper sliced raw with avocado and olive oil. The form is flexible. A whole pepper roasted and served alongside dinner. Half a pepper sliced raw with a few walnuts and a drizzle of olive oil as an afternoon snack. Diced into scrambled eggs in the morning. The preparation method that you will actually maintain week after week is the right one. The consistency is what matters. What I want you to carry from today is the connection between a specific gap in the typical diet of older women and a specific, measurable, addressable risk. The fact that women over 65 develop and progress through AMD at higher rates than men is not simply a matter of biology that cannot be influenced. Part of that difference reflects dietary patterns that are not fixed. Part of it reflects a zeaxanthin gap that can be closed with a vegetable that costs less than $2 and takes 5 minutes to prepare. The research does not promise that orange bell pepper prevents all macular degeneration in all women. It shows that women who eat it regularly have meaningfully better outcomes than women who do not. That is a meaningful distinction, and it is one that is entirely within reach. The tenfold shortfall in zeaxanthin intake that characterizes most women over 65 is not an inevitable feature of aging. It is a nutritional gap that can be addressed with a food that is inexpensive, widely available, and genuinely pleasant to eat. The women in the research cohorts who showed the lowest AMD rates were not following complicated protocols. They were eating zeaxanthin-rich foods regularly. That is the entire intervention. That is what the data points to. I want to hear from you now. After today, are you going to add orange bell pepper to your regular shopping? Tell me in the comments. And if you already eat it consistently, how do you usually prepare it? I read every single response. If this was helpful, please hit the like button and subscribe for more evidence-informed guidance on protecting your vision and your health as you age. Share this with the women over 65 in your life. This information belongs in their hands. This is Dr. Taylor Simpson. Take care of your eyes. They are irreplaceable.